OEE and its application by Thilanka Heshyarukchi. Why we have to measure. What we gets measured you can get fixed it. If you don't know what your losses are, you can't fix them. What is overall equipment effectiveness, OEE? It is measure of the how well lines or equipment are utilized in relation to their full potential. It takes into consideration the cumulative impact of these factors. Equipment availability, equipment performance, process quality, importance of the OEE. Identify losses on a specific asset. Provide feedback to stakeholders involved in improvement activities, and accurately reflect the results of the improvement effort. Track facts and data to ensure root cause solutions to problems. Demonstrate improvement visually. Optimize productive capacity based upon facts and data. Use improvement resources to maximize the benefit to production capacity. Enhance ability to convincingly translate improvements into the language of management. There are 16 losses in total productive maintenance. It'll help identify all losses in a process related to man, machine and material. They can be grouped accordingly. Equipment-related losses. Losses relating to manpower. And losses relating to resource consumption. OEE focused on reduce or eliminate the equipment losses. Following equation used to calculate overall equipment effectiveness. OEE equals availability into performance into quality. Where do we start? Let's start at the beginning, with calendar time. It includes every minute of every day, every week, month, and year. From calendar time, you subtract shutdown losses, which includes all time that should be excluded from OEE analysis, because there is no intention of running production during this time. Example, plant shutdowns, breaks, lunches, holidays, or periods where there are no orders. The remaining time is your loading time. OEE begins with loading time and scrutinizes all efficiency and productivity losses that occur within that time, with the goal of reducing or eliminating these losses. Loading time is the time that manufacturing equipment is expected to produce. Now we look at the 3 OEE factors, each of which takes into account a different type of loss. They are availability, performance, and quality. Availability takes into account of availability loss, which includes any events that stop planned production for an appreciable length of time, usually several minutes, long enough for an operator to log a reason. Examples of things that create availability loss include planned and unplanned stops. Unplanned stops, such as equipment failures and setup and adjustment. Planned stops, such as changeover time and startup and shutdown. Changeover time is included in OEE analysis, since it is time that could otherwise be used for manufacturing. While it may not be possible to eliminate changeover time, in most cases it can be significantly reduced. Reducing changeover time is the goal of SMED, single minute exchange of dies. The remaining time after availability loss is subtracted is called operating time. Performance takes into account of performance loss, which accounts for anything that causes the manufacturing process to run at less than the maximum possible speed when it is running, including both slow cycles and small stops. Examples of things that create performance loss include machine wear, substandard materials, misfeeds, and jams. The remaining time after performance loss is subtracted is called net operating time. Quality takes into account manufactured parts that do not meet quality standards, including parts that need rework. Remember, OEE OEE, quality is similar to first pass yield, in that it defines good parts as parts that successfully pass through the manufacturing process the first time without needing any rework. Here is an interesting example. Loading time is 460 minutes, and there were 60 minutes of availability loss. Since that operating time is equal to 400 minutes, availability rate equals to operating time divided by loading time. Availability rate equals to 0.87. Standard cycle time is 0.5 minutes per unit, and produce 400 of units. Performance rate equals to standard cycle time into number of unit producers divided by operating time. Performance rate equals to 0.50. Out of that 400 units there were 8 rejected units. So, quality rate equal to number of quality units produced, divide by total unit produced. Quality rate equals to 0.98. Finally, we can calculate value of overall equipment effectiveness. OEE equals to availability into performance into quality. OEE equals to 0.87 into 0.50 into 0.98 into 100, which means final OEE value equals to 42.6%. An OEE score of 100% is perfect production, manufacturing only good parts, as fast as possible, with no stop time. An OEE score of 85% is considered world-class for discrete manufacturers. For many companies, it is a suitable long-term goal. An OEE score of 60% is fairly typical for discrete manufacturers, but indicates there is substantial room for improvement. An OEE score of 40% is not at all uncommon for manufacturing companies that are just starting to track and improve their manufacturing performance. It is a low score and in most cases can be easily improved through straightforward measures. Example, by tracking stop time reasons and addressing the largest sources of downtime, one at a time. Now let's work through a complete example using the preferred OEE calculation. You can practice OEE calculation with this given example. Further, you can measure your organization OEE score. Thank you very much for watching this video. See you again in next lesson.